Hello. In this problem, you're asked to multiply and simplify completely this expression, which actually is called the square of a binomial. But before we begin, let's review the rules for exponents. So 2 squared means 2 times 2. 2 to the third power, or 2 cubed, means 2 times 2 times 2. Now, if you have a negative base and your desire is to expand it 3 times or multiply it by itself 3 times, you must put it in parentheses. I just want to make a note that this is quite different. While I'm here, this is quite different than 2 cubed, which actually means negative 1 times 2 times 2 times 2. Now you wind up with the same answer in this case, but if I had given you negative 2 to the fourth, then this would mean negative 2 times negative 2 times negative 2 times negative 2, which would equal 16. Now, in contrast that to negative 2 to the fourth, which would mean negative 1 times 2 times 2 times 2 times 2, and the final answer would be negative 16. But that's another issue. Okay, next. If you have the base being xy, and you square it, this means that you're taking the square of this term xy, which means xy times xy, which, if I want to simplify, this would bring me to x times x is x squared, y times y is y squared. Okay, now we get to the square of a binomial. This means, by extension here, that you're taking x minus 3 and multiplying by itself. And then you have to distribute 4 times here, and then you wind up with your final answer of x squared minus 6x plus 9. All right, now we're up to the original problem that was given to you at the top. Again, this is the square of a binomial, which means you have to multiply 3x minus 4 times itself. Again, we distribute 4 times, and collecting like terms here, you wind up with 9x squared minus 24x plus 16. All right, what I'm really concerned about is this particular common error that I see very often. If you're given the square of a binomial, some students will, I guess, take the power of 2 here. They take the power of the 2 and they distribute it to each of these terms, and they take 3x squared, which is 9x squared, and then 4 squared is 16. Well, it turns out to be this is absolutely incorrect. When you see the square of a binomial, remember that it means this binomial times itself, and that you have to distribute and wind up with a trinomial. Again, this becomes 9x squared minus 12x minus 12x plus 16, which again in turn equals 9x squared minus 24x plus 16. And you can clearly see that this is the correct answer and very, very different than the incorrect answer. So please be careful. All right, the next example is the square of 5 minus 2x. What do? We multiply this binomial times itself. Again, distribute 4 times, collect the like terms, and then you wind up with your trinomial 4x squared minus 20x plus 25. All right, for the next example, I'd like you to write it down, pause the screen, try the example, and come back and check to see if you're correct. Okay, what does this mean? Well, when you have, again, the square of a binomial, you take that binomial and multiply it by itself, distribute here, and then collect like terms, and you have your final answer here. I have another problem I'd like you to try just for fun. So this is just for fun. Okay, so the problem is negative on the outside, I don't know, 6x plus 5. Okay, put your screen on pause and come up with the final answer. All right, so what does this problem mean? Well, it means that there's a negative on the outside, which means negative 1 times the square of a binomial, which means 6x plus 5 times itself, 6x plus 5. And we wind up with negative 1 now times 36x squared plus 30x plus 30x plus 25. Collecting like terms on the inside, we wind up with a trinomial of 36x squared plus 60x plus 25. And then the final answer you have to distribute by that negative 1 on the outside, and the final answer is negative 36x squared plus 60x, minus 60x minus 25. And there is your final answer.